At elevated temperatures, dinitrogen pentoxide decomposes to nitrogen dioxide and oxygen, which you can see in the chemical reaction, the balanced chemical reaction that is shown. When the rate of formation of O2 gas is 5.5 times 10 to the minus 4 molarity per second, the rate of decomposition of N2O5 is how much molarity per second? So let's do this. Let's say rate is equal to minus 1 over 2, since I have a coefficient of 2 here, times the concentration or change in concentration of N2O5 over a change in time. And that also equals 1 over 1, since my oxygen has a coefficient of 1, times the change in concentration of O2 over a change in time. Okay? And so, given that this is a coefficient of 1 for the oxygen, the rate of formation of the oxygen is the same as the rate of the overall reaction, which I've written here in red. So what we can say is that 5.5 times 10 to the minus 4 molarity per second is equal to, we can figure out what we're trying to solve here for, equals minus 1 over 2. And remember that minus is because we're talking about a reactant that's decreasing in concentration, or decreasing with respect to time, right? Okay, so now this change in N2O5 concentration over change in time is what we're trying to solve for. So the way we do that is we just multiply both sides by -2. Okay, and we get delta N2O5 concentration over delta T equals, this is 1.1 times 10 to the -3rd molarity per second, which is answer choice C. And what that tells us is that the N2O5 will decrease at twice the rate that the O2 will appear. That rate is half as much. The appearance of O2 is half as much as the disappearance of N2O5, given that 2-to-1 stoichiometric ratio.